Different memory areas in Java. What all are the different types of memory areas in Java? Heap, stack, metaspace, PC register, native memory. So understand where your Java objects really live. Why memory areas matter? Understanding the core of Java execution. It helps debug out-of-memory error, improves performance tuning, crucial for GC and JVM internals. Obviously, it is frequently asked in interviews. So, JVM memory model overview. The 5 core pillars of JVM memory management. Heap memory store objects and arrays is shared. Stack memory stores method frames and local variables. It's per thread, it's available, so it's thread local. Metaspace or method area stores class metadata and static variables. It's also shared. Program counter register tracks current instruction address. It is also thread local. Native method stack for native JNI methods like C, C++. It is thread local. This is an overview of 5 core pillars of Java memory management. We can go one by one in detail. So this is the architecture. Here you can see two big blocks, shared memory and thread local, thread memory. So shared memory is heap and metaspace. Okay. So in heap, objects and arrays lives in heap, and metaspace holds class metadata and static variables. Okay, means metaspace having the class definition, static variables, etc. But heap memory holds the actual objects and arrays. So in heap memory we will have, for a particular class we can have a number of objects, right? These objects going into heap memory. Okay, so heap memory, you can see it is referring to thread memory, per thread memory. It is it's a logical grouping only. Okay, these stack, PC register, native stack are not shared. Heap and metaspace is shared across all the threads, but this stack, PC register, native stack, these all are thread local. Per thread there will be separate stack, separate PC register, separate native stack. Okay, in the diagram you can understand easily. Thread 1, thread 2, thread 3 having separate stack, PC register and native stack. So heap and metaspace exist once per JVM, while stack, PC and native stack are created per thread. It's clear, right? Heap memory, the core storage for runtime data. Okay, it stores objects and arrays shared across all threads, managed by garbage collector, largest memory area in JVM. Okay, so this is the core of JVM. It is like largest memory area in the JVM. So all the objects resides here. It shared across all the threads, and garbage collector is will clean up the heap memory based on its references and all. So it is managed by garbage collector. This is about heap memory. Then heap structure, generations and garbage collection flow. We can understand it from here. So whenever you are creating a new object, first it will go to the hidden space. Okay, we have two blocks, young generation, old generation. So short-lived objects are in young generation, long-lived objects are in old generation. So initially an object will goes to the young generation in the hidden space. From there, after one cycle, GC cycle, it will move to, if it survives, it will move to S0. If it survives again GC, it will move to S1. Then if it survives multiple GCs, means it will get a promotion to old generation long-lived objects. Okay. So objects surviving multiple GC cycles move from survivor spaces to old generation. GC means garbage collection. Okay. So if an object survives from multiple garbage collection, it will get promoted to old generation. That is the idea. So short-lived objects are in young generation, long-lived objects are in old generation. Heap example. Okay. Here I have a class user with an integer variable ID, and I am creating a new object u with new keyword new user. Okay. So here in the right side you can see local variable u is in the stack, but it references the object from heap. So the actual object resides in the heap. Okay, user object resides in the heap. But in the stack, we have a reference to that object. That is the purpose of stack. Okay. So the stack having the reference to heap, so that it can fetch the object from the heap. So stack memory. This is a efficient thread local execution. So it stores method frames, primitive variables, and objects references. Okay. It stores primitive variables and object references, and it is completely thread specific. No concurrent access issues here, because it's per thread one stack memory is available, right? So it is completely thread specific. Concurrent issues will never come. Fast allocation and deallocation. It is uses from the stack itself. It's a LIFO, last in first out. So it's a last in first out structure. So fast allocation and deallocation is there. It is automatically managed, cleaned up when method exits. Means this memory is automatically managed. If a method exits, it automatically clean up the particular variables. Okay. So inside a stack frame, components created for each method calls. So it stores local variables, primitives, and references. Contains operand stack for intermediate operations. Means if you are doing a mathematical operation, so there will be some intermediate results, right? That results also will be in stack. Okay. Holds return address for execution control. Okay, it holds the return address of this particular execution. Then frame is destroyed automatically after method exits. if you have a method calculate, you are doing some performance and all, and once you return this, or you exit from the method, that data will get removed, destroyed. So stack example, method execution and local variables. So you can see a method calculate. It have x and y, two integer variables. So variables x and y are primitives. It is stored directly inside the stack frame. Frame is popped when method ends. Okay. So right side you can see a stack. In the stack you can see x variable is there, y variable is there. Once we exits from this calculate method, this will get removed. Then their frame is destroyed automatically when calculate finishes. This is an example of stack allocation. Okay. So when will you get a stack overflow error? Okay. One case is infinite recursion. During infinite recursion, you will get stack overflow error, because the recursion will store the intermediate results in stack, because it's a method, right? Whenever you are exiting from this method, then only that frame will get destroyed. So if it is an infinite means it will keep on adding to the stack. Finally, you will get a stack overflow error. It's a runtime exception till you get a stack overflow error. JVM stack space exhausted. Okay. Method area or metaspace. The blueprint storage for Java classes. It stores class metadata, includes structure, methods, fields, and bytecode. Holds static variables, stores class level variables and references. So Java 8 plus uses metaspace. Before it was method area, but after Java 8 it is metaspace. It is replaced. PermGen uses native memory and auto expands. Okay, so this advantages of metaspace is it replaces PermGen and it uses native memory and it automatically expands. So what is the difference between PermGen and metaspace? Okay, evolution of class metadata storage. So Java in PermGen is a legacy thing. So Java 7 and below uses PermGen. Metaspace is the latest modern. So Java 8 and above uses Metaspace. So location, PermGen is inside heap memory and Metaspace is in native memory, operating system native memory. Okay, size and limit, PermGen have a fixed size. So it can throw out of memory error if that size exceeds. But Metaspace is auto expandable, limited by OS RAM. So the less chance of getting a out of memory error. Why the change means moving metadata to native memory eliminates the difficulty of tuning the fixed size PermGen and reduces java.lang.outofmemoryError PermGen space. So mainly it reduces the chance of getting out of memory error. That is advantages of Metaspace. So Metaspace example, you have a class config, you have a static integer count equal to 10. Then you can see in the metaspace this class details are holding in metaspace config.class.metadata, and you can see config.class is in the metaspace. Methods you can see main, fields, count, type window, int, these all things, because integer variable is static, that's why it came to the metaspace. Okay, because it is class level, all the class level things are holding in the metaspace. Object level things are going to shared heap. Here the value equal to 10, count equal to 10 means it is going to the shared heap. Okay, because it's an object, right? So this is how the metaspace works. So metaspace holds class metadata, static variables, the method names, and the type of variable, everything it holds in the metaspace, but objects are in heap. Out of memory error metaspace. Okay, class metadata exhaustion. So when you are iterating infinitely, you will get an out of memory error like this. Here what exactly you are doing means you are in a while true means it's an infinite loop. It is keep on creating the object and setting the superclass, and it's setting the use case equal to false. Is creating means new class is keep on creating new class in an infinite loop. Okay, because you are keep on creating a new class in an infinite loop means all these are going to the heap and it will go to the metaspace because new classes are creating. So all the class metadata goes to metaspace, right? So metaspace will exhausted at the end whenever the allocated memory exceeds. So that you can see a runtime exception java.lang.outOfMemoryError Metaspace. So in java.lang.outOfMemoryError, after that error, it will print Metaspace or heap or which area got exhausted. So that you can understand, okay, Metaspace is full, that's why I got this java.lang.outOfMemoryError. Okay, so here we created infinite number of classes, that's why Metaspace thrown an error like OutOfMemoryError. It is the given code creates infinite unique classes. So program counter, next one. Okay, this is small. It is the tracking thread execution. Stores current instruction address. So Java needs to know what is the current instruction, what is the next instruction, like that. Then only it can execute one by one, right? So program counter helps for it. It stores the current instruction address created one per thread. For each thread there will be a PC register. Okay, so helps JVM know the next instruction. So PC register tells the JVM execute this instruction after this, then this, like that. So that is the purpose of PC register. It's a very small memory footprint, no out of memory error. Okay. So next one is native method stack. It is bridging Java with the system libraries. We know that system libraries are written in either C or C++. So Java bootstrap class loader, whatever java.lang.string, the core things are written in C or C++, right? So Java uses this native method stack to bridge the system libraries with Java. Okay, so native method stack used by JNI and native methods is written in C or C++, separate from Java stack. It is not comes in the Java stack. It is C or C++, written in C or C++, C bar C++, and it is used by JNI bar native methods. Okay. So native stack error. It is platform dependent. Okay, the native stack is platform dependent. It is JNI, and you can see the code here. It is not a Java code. It is a C++ code. In this particular C++ code, it is allocating a buffer size. So the Java native demo crash. If you run this code, this native memory will get exhausted. You will get a stack overflow error. Okay, so this is an example for native stack. This native stack, it is a stack only, that's why you are getting a stack overflow error. So we have two type of stack overflow error. Either you can get it from native stack or you can get it from our Java, the normal stack. Okay, so string constant pool. What is a string constant pool? So if you have two string variables s1 and s2, both are holding same value, then Java will not create two different objects for that. It will simply create one. It will allocate in a single string constant pool, so that this Java string is available in the constant pool means it will add a reference in the stack. Okay, now you understand the purpose of stack and heap in little more clear, right? So the string constant pool is in heap memory, and if you are creating again s3 equal to Java, it will add s3 in the stack only, then it will add a reference to string constant pool. So new Java will not get created. if we are using new keyword, it will get created. Okay, new means it allocates a new memory location with Java. But here we are not using the new keyword. We are simply assigning string s1 equal to Java. So it is going to the string constant pool, and it is reusing by multiple variables like s1, s2. Okay, so stack holds the reference and the values are in heap. You understand, right? Where does everything go? So we came across multiple memory areas. So where does it go? New object instance will go to heap. Object reference bar variable goes to the stack. Local primitive variables will go to the stack. Class metadata and class level static variables goes to Metaspace. String literal hello go to the string pool. Okay. Next, JVM options. So when you are running the program, you can give these options. These all are related to memory. Okay. Minus XMS sets the initial heap size. Okay. Minus XSS sets the thread stack size. Minus XMX sets the maximum heap size. Minus XX max meta space size limits the maximum memory used for class metadata. Okay. So if you are giving, why are we using this means, if you need more memory, you can make use of this JVM options. If you want to reduce for that also you can use, so that it will make sure at runtime the whatever option we given, that much memory will get allocated. Okay, so here you can see an examples of it. For each one you can see examples here. So this you can use while running your Java applications. These all are Java JVM options. So common interview questions. Why is stack memory faster than heap memory? Where are static variables stored in Java 8+? Why did Metaspace replaces PermGen? So you know the answer, right? Stack uses simple LIFO access and manages memory automatically as method exits. Heap involves complex allocation and global garbage collection overhead. That's why stack is faster than heap. Okay. The value object is stored in the heap, while the class metadata describing the variable resides in the metaspace. Okay. Then PermGen had a fixed size, leading to frequent out-of-memory errors. Metaspace uses native memory and can auto-expand, making it more stable and dynamic apps. So the best practices: prevent memory leaks, close resources, streams or connections using try with resources, use weak references for caches. So what is the weak reference? If you want to know, I have already done one video regarding this multiple type of references. Then limit static variables. Static objects persist for the application's lifetime. Overuse leads to permanent heap blow. So limit static variables. Then monitor and profile. Don't use performance. Enable GC logs and use profilers to visualize object allocation. That you can use tools like Visual VM. You can monitor everything. Okay, you can there are many ways to monitor. So you monitor and profile to know is there any memory issues. Okay, then tune memory consciously. Set explicit boundaries via minus XMS minus XMX matching your workload needs. So understand your memory requirements. According to that, allocate memory using minus XMS and minus XMX. Okay. So I am going going to summarize what we discussed today. In Java, there are multiple memory areas. The JVM is not just one block of memory. It is segmented into distinct areas: heap, stack, metaspace, native method space, etc. So, it is optimized for specific data types. Shared memory. Heap and metaspace are shared across all threads. This is where objects and class metadata live. Access requires synchronization. Thread local memory. Stack and PC register are private to each thread. They handle method execution, local variables, and are thread safe by design. Better development. Understanding these areas help you troubleshoot out of memory error and write more efficient memory conscious code. Understanding memory equal to better Java developer. Okay, now I covered most of the slides, but I can give you some demo. Okay, I am going to the demo now. So I am going to one by one. First is Metaspace out of memory demo. Or okay, I can go to the heap out of memory demo first. Okay. This class I already created. So it's a class. Here a list of bytes. It's an infinite loop. Adding new byte means I am keep on adding 10 MB in each iteration. Means it's an infinite loop, right? It will definitely throw an error. So you can see I got an error here, Java heap space. It's an out of memory error, but it is clearly mentioned Java heap space. Here you can see minus XMS is 50M, minus XMX is 50M. So I reduced the size to get the error. Okay, I configured for getting an error. If this particular memory is getting full, throw me an error. Otherwise, it will throw error, but it will take some more time because the memory needs to get full, right? Till that time, it will run and it will throw error. So here I reduced the memory to get the error faster. Okay. So what happened here? You can see we are adding, keep on allocating memory. Memory in the sense heap area will get full. New objects, new entries are getting added to the list, right? So list is an object. Okay. And if you keep on adding means it will go to the heap and the heap will get full. And in each iteration you are adding 10 MB. That's why you got an error from heap space. So next I will show you Stack Overflow. Here I have a recurse method. It will call recursively. So in the main method I am calling the recurse method. It will keep on calling, and finally there are no conditions added here. So finally it will throw an error. So you can see this code executed and many times, but whenever the stack is full, I got an error. So I'm going to the top of this. It is Stack Overflow error. Okay. So here why here also I mentioned minus XSS equal to 256K means this sets the limit for stack. If this particular size exceeds, it will throw a Stack Overflow error. Okay. So here I got a Stack Overflow error because I am using a recursion without a proper condition. It's kind of infinite. Next, I am going to Metaspace out of memory demo. In Metaspace out of memory demo, I am running the code. You can see list class loader. I have a list of class loaders. Okay, it's an infinite loop. In class loader, I creating new class loader. Again, I am into the loaders list. I am adding this class loader. Here proxy.getProxy class cl comma runnable.class. What it will do? It will keep on creating classes, means the metaspace will get full. If we are keep on creating objects, heap will get full. Here we are keep on creating the metaspace. That's why you got this error. If I go to the top, out of memory error you are getting from metaspace, because if you are creating classes means it will go to the metaspace. That's why it is mentioned metaspace here. Next, the native memory demo. Here some byte buffer array I created, and I am adding allocate direct, byte buffer dot allocate direct. It is coming from java.nio. Okay, so this thing will allocate memory to native memory. Okay, if I run this, you will get an error saying cannot reserve these bytes of direct buffer memory allocated, because this is the allocated memory, but limited to this, means it is full. After that you cannot allocate. So this is how the native memory throws the error if it is full. Okay, so native memory, it is normally we will not use. It is used by JNI. It is written C and C++. So for the system libraries and all, this uses. Okay, native memory. Okay, next, native thread out of memory. It is again, you can see a demo here. I am running a thread. You can see it ran till 2018. Then after that it thrown an error, because this thread is unable to create, because out of memory error, unable to create native thread, possibly out of memory or process bar resources limits reached. So this is another way of error. This is another error we will get if this particular native memory is full. Okay, here you can see the code. In new thread I can keep on creating new threads. That's why you got an error like this. It's again an infinite loop. So GC overhead demo. Here if you see, GC means garbage collection. Okay, whenever you are creating a list and in a infinite loop you are keep on adding some random UID. So at the end you got an error, Java heap space is full, because my heap space I already mentioned, this is my memory. So after this memory is full, I am getting this error. Okay, this is all about different types of memory in Java. If you found this helpful, please like, subscribe and comment. Okay, which memory area confuses you most? You can add a comment. Maybe I can explain it. I can give reply in a better way. Thank you so much for watching this. Thank you. Bye.